In this video, we'll look at how to simplify fractions with powers. In the past, we simplified fractions using two different methods. First, we had to look for a number that could be divided into 12 and 16. So we can divide, let's say, by 2 first because they're both even, and 12 divided by 2 will be 6, 16 divided by 2 would be 8. Then we have two even numbers again can be divided by 2. 6 divided by 2 would be 3, and 8 divided by 2 would be 4. So your simplified fraction 3/4. Some may notice that 12 and 16 may be divided by 4 right away, and 4 going into 12 3 times and into 16 4 times gives you the same simplified value. And those 2 and 2 will be 4 in two different steps. And another way of simplifying was using prime factorization, where 12 can be written as 2 times 6, where 6 is 2 times 3. So the prime facts of 12 would be 2 times 2 times 3. 2 times 2 is 4, and then 4 times 3 is 12. And 16 can be written as 4 times 4, where each 4 is 2 times 2. So the prime facts of 16 would be 2 times 2 times 2 times 2, where 4, 2 times 2 times 2, 8 times 2, 16. And simplifying is by looking at the common facts and dividing. Fraction means division, so we can simplify by 2 divided by 2. 2 divided by 2 is 1. And 2 divided by 2, looking at the common facts, 1. 1 times 1 remaining facts times 3 is 3. 1 times 1, 1 times 2, 2 times 2, 4. Multiply back the remaining facts, and that's 3/4. Same exact value in two different ways. So we're going to use something similar to prime factorization when it comes to powers, because we can expand our powers, and we will simplify fractions with powers in 3 steps. So first step, write out the powers as expanded form. So we are going to expand the exponent, or write out the powers in expanded form. We will simplify the common facts, like I was showing using the prime factorization. Common facts we will simplify, and then we will collect the remaining facts on the numerator and denominator for the final answer. So, for example, I have to simplify a fraction that has 2 powers. That's quotient of powers, or dividing 2 powers, which looks like a fraction. So what I'm going to do is use the expanded form to figure out my answer. In the fraction, we have a numerator, and on the numerator I have x to the 5th power. That means the base x is multiplied by itself 5 times. 1, 2, 3, 4, 5. On the denominator, I have x to the 3rd power, which means x is multiplied by itself 3 times. That was step number 1. Write out the powers in expanded form. So we expand it as multiplication of bases. Simplify common facts. Common facts can be divided or simplified, just like numbers. Let's say if that was 3 divided by 3, or 5 divided by 5, or 7 divided by 7, we can simplify common facts. So every number divided by itself will be a 1. So here we have 1, or you can say x divided by x is 1. Another x divided by a common x will be another 1. And then we need to collect the remaining facts on the numerator and denominator. So what we have on the numerator is 1 times 1 times 1. The simplified x values have 1, which is multiplied times x times x. So x multiplied by itself twice is x to the 2nd power. And then on the denominator we have 1 times 1 times 1. Any number divided by 1 is the same number, so I can write my answer as x to the second power. So then, after we simplify, we collect back the remaining facts. Let's see another example. N to the 4th divided by n to the 9th. So that is a fraction, which is a division of 2 powers. To simplify, we're going to use the expanded form. So I have on the numerator n times n times n times n. That is n multiplied by itself 4 times. On the denominator, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. N's multiplied because the exponent says multiply n by itself 9 times. Then we will simplify the common facts. N divided by n is 1, n divided by n is 1, n divided by n is 1, n divided by n is 1. Step 3 says collect all the remaining facts on the numerator. 1 times 1 times 1 times 1. If you multiply, that is 1 on the numerator. On the denominator, we have 1 times 1 times 1 times 1. And then we have 1, 2, 3, 4, 5 n's multiplied by themselves, written back as exponential form. We are going to have 1 on the numerator. This time it's important to make sure we have 1 on the numerator, and then n to the 5th on the denominator. By looking at the beginning and the end, or the original problem, you can see that the exponents are subtracted and the higher exponent is still on the denominator. So the lower exponent gets simplified and the higher exponent is still on the denominator. We had n to the 9th, 9 minus 4 is 5, so the 4 n's of the numerator gets simplified, and n to the 5th is remaining on the denominator. Just making observations before we look at the rule. So first we are going to observe how powers get simplified through common facts and expanded form. So x to the 3rd power on the numerator means x times x times x. Y to the 2nd power times y, denominator x times x, and then y to the 5th. And I like to line them up, so I'm gonna put the multiplication of my y by itself 5 times lined up with the y's. That way I can see my x values clearly. One of them is still sticking out here, my y values, so I have more on the denominator. That way when it's lined up, it's easier to simplify. Second step, simplify the common facts. So we have x divided by x, and again x divided by x, and one of them is still left over. Y divided by y is 1, y divided by y is 1. So when in step 3 I collect my remaining facts, I have this x right here times 1 times 1 times 1, which is still x, on the numerator, and then the x's of the denominator got simplified, and I have 3 y's, that means y to the 3rd power, back in the exponential form. So what does that mean? If I look in the beginning, I had x to the 3rd and x to the 2nd. The higher exponent of x was on the numerator, that's why I still have the x on the numerator, and the higher exponent of y was on the denominator, so the lower exponent got simplified and subtracted from 5. Now I have y to the 3rd on the denominator. When we have numbers and the base and variables, we need to simplify the numbers as well, and then the variables. So for example, I have 4 and then expand a times b on the numerator. Then I have 12 and expand, I don't have any a's, but I'm going to bring the b over here just because I like it to be lined up. When it comes to coefficients or numerical bases, we have to simplify those as well. So like 4/12 is a fraction that can be simplified, and we can divide 4 and 12 by 4, or I can divide by 2 and then by 2 again. But if I divide 4 by 4, I have 1. And if I divide 12 by 4, I have 3. So that's 1/3 as remaining facts for the coefficients that are the number bases. B can simplify the common B, 1 on the numerator, 1 on denominator. You're dividing B by B, that would be 1. And A did not simplify at all, so it's still A to the second power on the numerator. That can be written as A to the second power, because A to the second power times 1 is still A to the second power over 3. Let's see another example with coefficients or numerical bases, and variables. So we have 20 times n multiplied by itself 3 times m. 18 times n 1 time, and then m 4 times. 20 and 18 can both be divided by 2. So if I divide by 2, 20 divided by 2 is 10, 18 divided by 2 is 9. Simplifying the common facts, n divided by n, and m divided by m. Then look at the remaining facts on the numerator and collect them back for the answer. So we have 10 and then n to the second power. On the denominator we have 9 times 1 times 1, which is 9, and m to the third power. In the final answer, you need to have just n variable and m variable, so you can't have an n again on the numerator and denominator, because they have to simplify in the process of finding the common facts. One more example. We have 2 on the numerator times a times b times b. Write the bases in expanded form. 6 times a times b times b times b times b times b multiplied by itself 5 times. 2 and 6 can be simplified by dividing by 2, so that would be 1/3. A can divide the a. Any number divided by itself is 1. B can divide the b. B can divide the b. Now, when you collect again all the numbers on the numerator, that's 1 times 1 times 1 times 1. So that means in the final answer you have 1 on the numerator. There is always that 1 remaining, because in division, dividing a number by itself, the answer is 1. So when we simplify, we have 1. 1 times 1 times 1 times 1, that's 1. And then 3 on the denominator, and b to the third power. The 1 on the numerator must stay.